So we're going to start by looking at problem 28 from yesterday because that seems to be the one that's giving people a lot of fits as far as that goes. But it kind of works along with what we're doing today, so it's kind of nice from that standpoint. Problem 28 is the one where they gave us 3 points and we had to find the fourth point of the parallelogram. And we had some problems with it primarily because we could kind of set things up in the wrong order and you wind up with a different fourth point. And I'll show you exactly what happened there. Honestly, if you did it the other way on a test or quiz, I would probably give it to you. But we're going to show you that both ways that things are handled here. So our points are at D, -2, -4. So the point D was at -2, -4. There we go. E was at, we didn't know. F was at 0,7. And G was at 1,0. It's kind of a tall, skinny parallelogram. Now, it kind of depends. Our fourth point could go a couple different places depending on how we connect these points. It's supposed to be D, E, F, G. If I connect the points this way, then my fourth point's going to be down here somewhere, right? But if I do that, my parallelogram is D, F, G, and the fourth point E, isn't it? That's not the correct order for the parallelogram. We want to be D, E, F, G. Now, if you did it the wrong order, I'd probably still give it to you because you're getting the main idea of the problem, which is to create the parallelogram. But actually, the way it's supposed to go, if we do this, is E is the unknown point, so we connect F, G, and D, E, and E should be up here somewhere. If you got the wrong point, I believe you got the point like -1, -11. And if that's what you put in and it gave you a wrong answer, again, on a test, I'd probably give that to you. I'd probably say, okay, you got the big idea. Or maybe a very small point deduction, half point, quarter point, something like that. But ideally, this is the way we're going to do it. And again, to find the fourth point in a parallelogram, we just have to use the idea, well, what does a parallelogram mean? It means the opposite sides are parallel and congruent, right? So the side from D to E has to be parallel and congruent to the side F to G. From G to F, I went left 1 and up 1, 2, 3, 4, 5, 6, 7, right? The slope would be -7. Changing Y over changing X, so the 7 goes on top and the -1 goes on bottom. But that's okay, that's exactly what's going on. So in order to be parallel, I have to do the same thing. From D, I have to go left 1 and up 1, 2, 3, 4, 5, 6, 7. And I wind up there at the point -3, 3, which is the point we're looking for. And there is our parallelogram. That's what we're trying to do. Now, problems like that really help to have graph paper. If you don't have graph paper, you guys, most of you in here have been in here, you know where to find graph paper. Where do you find graph paper? Back there. It's free. I've got lots of it. If it starts running low, just tell me. I'll make more. Okay? Don't like take the last 4 pieces and go, we're out of graph paper. Please don't do that. Leave me one so I have something to copy. Okay? I don't want to have to restart. It's just, to leave me one, I can make 500 more. Super fast. So that was that problem that a lot of people kind of struggled with. We had less than 50% correct on that one. So definitely wanted to look that one over a little bit and working in the coordinate plane. All right. The nice thing about today and today's lesson is that we are going to be doing the converses of everything we did yesterday. 90% of what we do is exactly the same mechanically as what we did yesterday. But yesterday we asked the question, okay, if we know something is a parallelogram, what do we know about the parts? And there were 5 things that we knew. We knew opposite sides are parallel, opposite sides were congruent, consecutive angles were supplementary, opposite angles were congruent, and the diagonals bisect each other. That last one, the diagonals bisect each other, let's be really clear about what that means. If I have diagonal, diagonal, it means if the diagonals bisect each other, that this point is the midpoint for both diagonals, doesn't it? That's what bisecting each other means. It means they cross in such a way that they share the same midpoint. It doesn't mean the diagonals are congruent, but this piece is congruent to that piece, and that piece is congruent to that piece. That's what diagonals bisect each other means. And we can find that point by using the midpoint formula, with the endpoints being at the ends of the diagonals. It's not hard to do. All right, today we're going to flip it all on its head. We're going to say, okay, if I know that, or how can I know that something is a parallelogram? Okay? If I know I've got some sort of quadrilateral, how can I prove that that shape is a parallelogram? And essentially, it's going to be the same things we just did, but the converses. And we're going to have one bonus way. Okay? The first way I can prove something is a parallelogram is I can show both pairs of opposite sides are parallel. Okay? So if I can prove that both pairs of opposite sides are parallel, it must be a parallelogram. If I work in the coordinate plane, how would I show that sides are parallel? What formula do we use to prove that lines are parallel? Now, in order to parallel, we have to measure what of the line? The slope. Okay? So we would use the slope formula in the coordinate plane to do that. By the way, if you're taking notes, this is something you might want to jot down. These are the key ideas that we're going to be using today. That's one way I can prove something's a parallelogram. Another one, sorry, I want the skinny pen. Show both sides, or both pairs of opposite sides are congruent. Okay. How would I do that in the coordinate plane? If I was working in the coordinate plane, how do I show that parts are congruent in the coordinate plane? We did this with triangle congruence. How did I show congruent sides? What formula did I use to show congruence? Which formula measures length? Distance formula, yeah. So in order to show things are congruent, we need the distance formula. So if we're working in the coordinate plane, I can measure the lengths of all four sides using distance formula and show that sides are congruent. If I can show both pairs of opposite sides are congruent, it must be a parallelogram. Third way we can do this. Show both pairs of opposite angles are congruent. Again, it's just a converse of what we did yesterday. But if I can show both pairs of opposite angles are congruent, then it must be a parallelogram. Can I do that easily in the coordinate plane? Can I measure angles in the coordinate plane? Not easily. Not with any methods we've learned, unless it's a right angle. I can find right angles by doing slopes to find perpendicular lines, right? If I know that line segments are perpendicular, then I know I have a right angle. But that's kind of not often the case. So we really just don't try, for the most part, to prove that angles are congruent in the coordinate plane unless we're going for right angles. Okay? I could show all pairs of consecutive angles are supplementary. And again, since same thing, I can't really do that in the coordinate plane so well unless we have all right angles. Okay. I can show the diagonals. I spelled that wrong. Bisect each other. And what do we say for that? We just looked at that picture. What formula would I use in the coordinate plane to show that this is the same midpoint for both diagonals? Here's a hint. What formula would we use? To find a midpoint, we would use what formula? The midpoint formula. Shocking. Okay. So we could use the midpoint for formula for that. Okay. And that pretty much is a converse of everything, but we do have one special thing that we can do, and that is to show one pair of sides is both congruent and parallel. So we'd have to use slope formula and the distance formula on one pair of sides. Notice, this is not one pair of sides congruent and the other pair of sides parallel. That doesn't work. And I'll show you why really quickly here. I could have a parallel pair of sides. These sides are parallel. These sides are congruent. Is that a parallelogram? Clearly not. That is an isosceles trapezoid, which we will spend more time talking about in the second half of the chapter. Okay? So it can't be one pair parallel, the other pair congruent. That doesn't work. It's got to be the same pair of sides is both parallel and congruent. It has both properties. That's my final way of showing that something is a parallelogram. So we had 5 facts we could get from a parallelogram yesterday. Today we have 6. It's the converse of the first 5 plus one pair of sides, both parallel, ways to prove something is a parallelogram. Now, mechanically, this is not, for the most of your homework, this is going to be very straightforward. It's going to look exactly like what you did yesterday. You're going to see problems, maybe. Here are, by the way, the theorems. Problems like this. Quadrilateral WXYZ, W is 42, X is 138, Y is 42. Find the measure of angle Z, and is it a parallelogram? Explain how you know why. Yes or no? Now, I have a written description, but what am I lacking here? A picture. So what are we going to do? Draw a picture. Helps if I use not my eraser. There we go. So I draw what I think is a parallelogram. It says angle W is 42 degrees. X is 138. Y is 42. Okay? Now, we know the 4 angles have to add up to what? 360. So if I take 360 minus 42 minus 138 minus 42, I'll help you out. We come up with 138. Is this a parallelogram? How do you know? Because what? Opposite angles. Okay. The opposite angles converse theorem. Okay. Parallelogram, opposite angles, converse theorem. Both pairs of opposite angles are congruent. Again, when you do your drag and drop in your homework, what's the keyword we're looking for here? Opposite angles. Or I could use consecutive angles. All pairs of consecutive angles are supplementary, aren't they? So there's a parallelogram, consecutive angles, converse. We could use a definition of parallelogram, which is opposite sides are parallel, because guess what? And this will be a little bit trickier, but if I consider these 2 lines and a transversal, these consecutive angles are supplementary, which means XY and WZ have to be parallel. Ooh, that goes all the way back to chapter 3. And I wouldn't expect you to use that method, although somebody second hour got that one right off the top of their head, which was actually pretty good. Most of us would just go with the parallelogram opposite angles theorem, or converse, sorry. parallelogram opposite angles converse. And those would be my reasons why. It works out pretty nifty. Okay? Problems like this, really straightforward for the most part. Find the value of x that makes it a parallelogram. It really is the same problem you did yesterday, isn't it? What are we going to do? We're going to start by setting these two sides equal. I could start by setting these two sides equal also, but one has an x and one has a y, which isn't going to help me very much, is it? But the two x's, it's easy. I can do x plus 9 equals 2x minus 1. So subtract the x, add the 1, I get x equals 10. Once I know x equals 10, that means this side has to be 17, so y would also have to be, what would y be? 17, not 10. Y would be 17. Y is the same as x plus 7. X is 10, so 17. Okay? A lot of it's that simple. Here, which theorem are we using? We're using the diagonals bisect, right? Parallelogram diagonal converse theorem. Okay? What has to be true about those two segments with the x's? What has to be true? Those two values, those two variable expressions have to be set equal. Yeah. And solving that, again, I think you can handle. Okay? I think you can handle doing that. Okay, back to the coordinate plane. Find the distance between 2 points. I want to spend a fair amount of time today looking at the coordinate plane examples because that's where people run into some difficulty. When I give you 4 points in the coordinate plane, you have to prove to me it's a parallelogram. Now, we can use the opposite sides are parallel, both pairs of opposite sides are congruent, one pair of opposite sides is parallel and congruent, or diagonals bisect each other. We can use any of those reasons, and you just have to become decent at doing at least one of them. Actually, I think on the chapter test, I'm going to ask you to demonstrate using 2 different methods. So you might want to have a couple. So it's really essential at this point that we know slope, distance, and midpoint formulas, which should not be a surprise because you need to know them all for a semester too. So if we're going to find the distance between 2 points, as you've seen me do 100 times before, most of you, if you've been in my class, I like starting my distance formula by creating a template. Just a blank version of the formula without any numbers in it with just all the symbols. And then we pop the numbers in from there. It really is not a bad way of setting up your distance formula because if you have that, now when you plug your numbers in, you're less likely to make a mistake. Now, I still have some people who, take this -3 and 5 and pop them in the same parentheses. If they're in parentheses up here together, they can't be in parentheses here together in the formula. Or as I described in my second hour class, think of it like couples going to a party, okay? What happens when couples go to a party together? Oh, as soon as they get in, the guys go this way and the girls go that way, right? All the guys are talking over here, all the girls are talking over here. It's pretty normal. Well, these points are going to a party, and this is the party. They aren't going to stick together when they get to the party. They're going to split up, be with their friends. So the -3 wants to hang out with the 1, and the 5 wants to hang out with the 2. So getting the numbers in the right spots with the right symbols is great. Now we got to do our arithmetic. -3 minus 1 is -4. 5 minus 2 is 3. Now, here's the other big mistake people make, and it's a calculator mistake in many cases. People go to their calculator and they plug in -4 squared. So they keystroke this, they get a -4, and they hit their x squared button. And maybe that's equals or not. But what happens when you do that? What does the calculator give you? It's going to tell you -16. Why? Because the calculator knows order of operations. It's very smart and it's very dumb at the same time. It knows order of operations, so it does the 4 squared and then does the negative. Okay? We have to be smarter than the calculator in that we know that every number squared is positive. Every real number that we use. When you get to algebra 2, you get something called complex numbers, and you can square something and get something that's negative. But we aren't dealing with that yet. Okay? So I know that negative, be careful if you're entering it in your calculator. If you're doing this in your calculator, you really have to enter parentheses, negative 4 parentheses, and then squared. If you want to do it in your calculator. To tell it to multiply negative 4 times negative 4, not negative 4 times 4. Okay, got to be smarter than your calculator. Calculator will do what you tell it to do. If you put in negative 4 squared, you're telling it to take negative 1 times 4 times 4. So if you put negative 4 in parentheses squared, you're telling it to take negative 4 times negative 4, and it'll give you the right answer. Most of you should know what negative 4 squared is without the use of a calculator in anyway, though, right? Negative 4 times negative 4 is 16, which is the square root of 25, which makes us happy because that's a whole number of 5. Okay? I just too often, watching you guys' work, see negative 4 squared and see a negative 16 written down here and then the square root of negative 7, which of course we can't do, but doesn't make sense. So be thinking when you're working with your distance formula and know your distance formula well. All right, I want to prove that this quadrilateral is a parallelogram. Now, I can do it. You really have freedom of choice here when it comes to what method you want to use. Most people go straight for, let's prove the opposite sides are parallel. And we can do that really easily by finding the slope of each side. Now, when you're doing that, we have to communicate very clearly. That's really important. So if I'm going to start by finding the slope of AB, I'm going to write out, I'm writing the slope of AB equals. And now, most of us at this point are going to use the slope formula. Some of you will want to just count boxes and do it that way. You can just count boxes as long as you come up with the right solution. As long as you count carefully. Formula is a little safer. But slope, again, changing y over changing x, so that's 3 minus 5 over negative 3 minus 2, or negative 2 over negative 5, which is just 2/5. Then we find the slope. I'm going to find the parallel one right away. That would have to be CD. And again, if I count, it's plus 2 plus 5 is 2/5. So these are parallel. Then I'd have to do the same thing for the other two sides. Very clearly labeling slope of BC. Okay, finding the slope of one pair of sides is not good enough. Got to have the slopes of both pairs of sides. Slope of BC, 5 minus 2 over 2 minus 5, which is negative 3, or positive 3 over negative 3, which is negative 1. Slope of AD, 0 minus 3 over 0 minus negative 3 is negative 3 over 3, which is negative 1. Aha, these are parallel too. And then tell me what method you just used. I just found both pairs of opposite sides are parallel. Okay, So communication is really key as you're working on these problems in the coordinate plane. State clear, don't just write down random numbers or write 2/5, -2/5, or 2/5, 2/5, -1, negative. Don't do that because I don't know if that represents a slope, if that represents a length. I don't know what you're calculating. Be specific. Communicate with whoever's reading it, whether it's myself or it's Mrs. Moxley or it's Ms. Janzak or whoever is reading it should be able to tell exactly what you've done and what it is you're calculating, and then give the reason why in the end. Don't allow us to, okay, parallel, parallel, so what? Oh, if both pairs of opposite sides are parallel, then it's a parallelogram. Okay? Instead, if you want to do distance formula, you could do that. If you wanted to do diagonals bisect each other, a lot of people choose that method because it's kind of easier. We simply find the midpoint of that diagonal, and the midpoint of that diagonal show us the same point. Diagonals have the same midpoint, therefore they must bisect each other, making it a parallelogram. Okay? It's not two-column proof, but we still have to communicate well. It's coordinate plane proof. All right? That's what you're going to be working on. You will need graph paper for that. You will see that show up on your quiz. Now, speaking of quiz, we are scheduled for Tuesday. Obviously, you know, nobody really knows what's going to happen next week, weather-wise or anything like that. So, first thing you want to do is make sure you are staying tuned very carefully to, I'm sure you're going to be paying attention to whether or not school's canceled. I'm not worried about you checking on that. But if school is canceled, make sure that you are checking your email and your Schoology for things I might post there for you to work on. I'm going to, as soon as I locate it, hand out to you your review sheet for the quiz. I can find where I put those things. So you have that home with you this